Day of chemistry. So we are talking today a little bit more about careers in chemistry, like why are you taking this class? What could you maybe get out of it in your future? And it's also a way for me to continue to get to know you guys as well. In my survey yesterday, a lot of you said that you weren't sure about what you want to do after high school or what you want to do for your career. Some of you guys had a really solid idea about what exactly you wanted to do. And a lot of those things did actually involve chemistry. Whether you realize that it does or it doesn't, chemistry kind of sneaks its way into a lot of professions. I think the most obvious professions that use chemistry are going to be things like medicine, anything like a doctor or a nurse or even a veterinarian. They're all going to be very well versed in chemistry, but there's things you don't think about per se, like being a police officer and having forensic evidence. A lot of that is very chemistry related. Even things like being a hairdresser, you have to have the right chemistry to make sure that you're not going to burn your client's hair off, etc. So there's a lot that you can do with the information that we're going to learn in this class. And I want you guys to be thinking about that right off the bat. And again, like I said, again allows me to get to know you a little bit better. Like, what are your goals? Like, what interests you? How could this class potentially be useful to you in your future? So as we talk about careers in chemistry, I am going to start the day the way that I typically start the day. So I always start you guys off with a do now. So what are you going to do? Just like we did yesterday in our second video, you guys are going to log into Socrative, okay? So remember, in order to do that, there's a link in your virtual classroom that takes you to Socrative. But if you don't want to use that virtual classroom link, you can just type socrative.com. Remember what you guys are going to do. I'm going to take you off this page for a second. What you're going to do is you're going to click login and you're going to click student login. Okay. Remember your room name is going to be Chem Lewis 4 if you're in my 4th block, 6 if you're in my 6th block. And then you are going to type your student ID just as it would appear on your what's that called? Your ID card, right? Or like what you would type in for lunch. So you're just going to go ahead and make sure that that's what you guys are doing for, I'm sorry, I didn't realize I didn't switch over the tab. So again, room name is going to be Chem Lewis 4 or Chem Lewis 6. Student ID is going to be your student ID. Now, I just want to make this clear before I have you guys actually pause the video and continue with the assignment that I've posted there. First of all, just know that this is how you're getting attendance. I take your attendance whether you're online at home, whether you're in person at school, whether you're an all the time remote person or whatever the situation happens to be. To get attendance credit, again, remember your camera needs to be on while I'm instructing. And you also need to do this do now within the first 10 minutes of class. I will submit my attendance by the first 10 minutes of class. So if you happen to come in late, you try to log into Socrative and it's already closed down, what you're going to do is you're going to send me a quick email like, hey, Miss Lewis, I'm sorry, I came in at 9:10 or whatever time it was that you came in, and that way I can adjust your attendance as necessary and catch you guys up, okay? Remember, we're going to do it every day. And it should be something that's an advantage to you because it's kind of like a short practice quiz where you get like some instant results, some instant review. So if there's anything on the do now you struggle with, you'll know, oh, I need to make sure that I check in with Miss Lewis about this, or, oh, this is a good review for the quiz that we're going to have in a second. So at this point, this is your cue to pause and do the do now. When you are done with it, go ahead and flip back to this video and hit play. Okay, so what we're going to be doing today with this video and with your activity is you have 3 objectives. You should be able to explain the importance of chemistry. You should be able to describe the different fields of chemistry. And you should also be able to differentiate between pure and applied science, which is going to be kind of a theme for our entire course, is the pure science, the applied science. Okay? So your agenda today is pretty straightforward and simple. You just needed to do that do now, which you have already completed. We are going to go through really quickly and do some careers in chemistry notes. So I posted with this video your guided notes. You're going to make a copy of that document, and you're just going to fill it in as we go. And then you can submit that to me to prove to me that you watched this video, you got some ideas about what careers in chemistry there are from me. And then I'm going to send you guys off to do your graded assignment, which is careers in chemistry research. So the announcements here are, I would like for you guys to have your class supplies by Monday at the very latest. Remember that Thursday, 2 days from now, that's when I'm going to go ahead and start doing some notes formally in your notebook, because we're going to start hitting on topics that will be covered in quizzes, that will be covered in tests, that will be covered in your midterm. So I want you guys to have a reference for that. So if you don't have your college ruled composition notebook that looks like this by Thursday, that's okay. I just need you to have it by Monday, and you guys are going to take some notes on paper that I'll have you just like cut and paste into your notebooks, just so it's all in one place. Okay, so Thursday's ideal, but Monday, if you need that extra time to get out and get that. Remember that I also highly, highly, highly recommend that you guys have some sort of colored pencil pen situation. Like I said, I use colored pens in my notes, and you'll see, like, I straight up just take notes with you guys. And the whole reason I'm having you do that is because there's math that we're going to be starting to do pretty soon. And if you can follow along with my notes that are color coded, the math is so easy. And we're going to be talking about periodic table again soon. So for you to put into your notes where the alkali metals are versus the halogens, it's so much easier if you have one group is pink and the other group is green in your notebook. Okay, so there is a reason I'm asking you to have those. And then remember that syllabus contract is due. Some of you guys went through and did some of the assignments yesterday, but you should have done them all, especially because they orient you to the class. But then also, you should definitely make sure that the syllabus contract was signed, because that's something that is really important and due for this class, okay? More announcements just to kind of let you guys know, because it's the beginning of a new year and a new course for you guys. Today is your first graded assignment. Okay. The assignment that you're going to do at the end of the block goes along with the science skill obtaining, evaluating, and communicating information, which is skill 8. Okay. So remember, there's actually 8 total science skills, and the last grade in each category is the one that contributes to your overall grade. Now, this skill is not one that we hit a lot of times through the rest of the semester. So getting an incomplete or getting a 0 on this assignment is really going to end up dragging your overall grade down. So make sure that it's one that you pay attention to and that you complete to the best of your ability. And just as a review here, because there are 8 science skills, this is kind of the way that your grade is going to break down. Each of those science skills are going to represent about 12.5% of your overall grade. So you want to make sure that you are doing your best in every category to make sure your overall grade is as strong as possible when it comes to the end of this semester. Okay? All right, so we're getting into your notes section. So again, if you didn't already do so, take that careers in chemistry guided notes. You're going to hit the file, make a copy. So it goes ahead, it's just in your drive, and you can start filling in those blanks as we're talking here, just to show me, yes, you have done the work along with me as we're working here. So why would we study chemistry? First of all, it explains the natural world, and it explains the natural world on a level that you may not have actually gotten into yet. It just satisfies the human's natural curiosity and natural desire to understand how do things work. And now we're going to explain how do things work at an atomic level, so very, very small, very, very specific level. So, for example, chemistry can answer the question, why does an apple turn brown when you cut it and then it's just left out for a while, it's exposed to air? it's like oxidizing, right? Some of you guys might have known that term already, or at least have heard that before, right? How about why does the texture of eggs change from from runny to firm as eggs are boiled? So they go from being really, really soft or cooked in any way, right? And then they firm up. That's going to be the fact that the molecule itself actually changed. The protein gets denatured. And then how about this one? Some of you guys might not have been aware of this, but why does water expand as it freezes? You know that ice actually occupies more space than water does. And that has to do with a very interesting characteristic of water as a molecule. It's a polar molecule that forms a crystal lattice. Right, so we're looking at like the very fine details of molecules that explain all these natural phenomena. So also why study chemistry? It's important, especially I'm sure you guys are aware that it is voting season, right? So it's important that you guys understand the science of what's happening in the world because it helps you become an informed citizen. It helps you make the right choices as you're voting for propositions and ballots and even elected officials, right? So, what do I mean by that? For example, space exploration couldn't take place without federal funding. Critics argue that the money would better be spent on programs such as cancer research. So, like being an informed citizen in terms of science helps you make those decisions a little bit better. Knowledge of chemistry and other sciences can help you. Can help you evaluate the data presented. So, especially what's going on in the world right now, there's a lot of misinformation, and there's like bad data out there that is making people draw the wrong conclusions. So it's important that you know what data is important, how to evaluate that data, so you can make decisions for yourself versus just going along with what people have interpreted for you. So also preparing for a career. Chemists contribute to society in many ways. You don't need the word chemist in your job title to benefit from chemistry. Like you don't have to be a chemistry teacher to benefit from the knowledge of chemistry. So for example, like if you're interested in journalism, a reporter might be asked to interview a chemist to gather background for a story. Or lots of stories that are happening in the world right now do require that you have some basic level understanding of chemistry to really be able to report on what's happening. Even if you're interested in like sports or outdoors kind of careers, just being a turf manager, you can have the important task of keeping the grass on a golf course or a lawn or a soccer field healthy. And you actually have to understand a lot of like soil chemistry in order to do that appropriately. Same with firefighters. That's a lot of chemistry to understand there's different types of fire. There's different ways to put out different types of fires. So they have to know which chemicals they need to use, and they have to first of all be able to identify what type of fire they have, and then appropriately use the right type of chemical. So there's a variety of careers that require at least some basic understanding of chemistry. So, just moving forward, chemistry, technology, and society, having like this knowledge of chemistry, exploring more further uses of chemistry can help the environment and create a greener way of living. So there's a lot of trends for like bottles that are made out of plants, or green cleaning products, or electric cars, or solar energy. And all of that stuff actually really boils down to chemicals and chemistry. It also makes our lives easier and more comfortable. We get new technology from chemistry. We get new materials from chemistry, new medicines, which is very important. So all these things are coming from a knowledge and an advancement of knowledge of chemistry. So we also get to learn more about the universe as we learn more about chemistry. The use of technology to explore space, analyze chemical composition of rocks, liquids, gases. Like we know what the composition of Venus's atmosphere is, even though we've never been there. We know what's going on in Jupiter, even though we have not to any extent been able to get like samples of Jupiter, right? But the fact that we know how to analyze chemicals tells us what the chemical composition of these planets that we've never even been to is. So I have linked this into the link for your assignment for this one. I'm going to play it within this video just so you don't have to navigate away. But if it happens to slow down for you or something like that, then you can just click the link that is given to you.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct, but it's wordy and hard to
Graphene. Everybody's talking about it. When hearing some of its basic properties, you might have wondered if people were confusing it with some kind of substance only found in comic books. It's 1 atom thick, conducts electricity better than silver, conducts heat better than diamond, and it's stronger than steel. It would take the focused force of an elephant balancing on a pencil point to pierce through a piece of graphene as thick as plastic wrap. And yet, graphite is made of the same stuff. And yeah, that crumbly stuff used to make your pencil is a lot less impressive. So what's up? Graphene is made of carbon, and carbon has only 2 naturally occurring crystalline structures. Graphite, which is just stacks and stacks of graphene piled on top of each other, and diamond, which is a network of carbon atoms arranged into tetrahedrons, one after the other. For being composed of entirely the same element, those 2 things don't seem to have a lot in common. Diamond is clear, graphite is black. Diamond is a nearly perfect electrical insulator, while graphite is both a great conductor of heat and electricity. The differences between these substances all come down to the arrangement of their atoms. Carbon has 4 outer electrons. In diamond, all 4 of those electrons bond to carbon atoms around it, those tetrahedrons. This makes for an extremely rigid and strong crystal. It's an insulator because there are no leftover electrons to carry a current, and it's clear because light can't easily excite electrons that are tied up in such stable bonds, which is where they'd otherwise be absorbed. Graphite, on the other hand, is a crystalline form of carbon in which each atom is only bonded to 3 other carbon atoms. Those atoms form a 2-dimensional sheet of hexagons in which each atom has 1 unpaired electron left over. And those electrons will go flying across the matrix of atoms if you apply an electric current, allowing it to readily conduct electricity. They also gobble up any photons coming their way, which is why graphite is black. But while graphite is a great conductor, its natural form consists of layers of those sheets. So if a current is applied to it, those free electrons have lots of different directions they can go in, taking tangents up and down and left, right, and so on. But if you strip away just a single layer, forming graphene, then you have what amounts to an electron superhighway, a flat matrix of carbon atoms for that current to fly across. And those sheets of carbon are pretty easy to separate because they're not molecularly bonded to each other. That's why graphite is so soft. Instead, they're held together by van der Waals bonds, kind of a weak electrostatic bond that's the same force that makes sticky tape sticky. In fact, graphene was only discovered in 2004 when 2 physicists at the University of Manchester, Andrei Geim and Konstantin Novoselov, decided to use sticky tape to peel off thinner and thinner layers from the slab of graphite. Eventually, they got a layer just 1 atom thick. So that's what it is. But what is it good for? Because of its terrific conductive properties, scientists are excited by the possibility of using graphene as a replacement for silicon in microchips. Not only can electrons move faster across graphene, they're also subjected to less noise. That means the electron can move from one side of the sheet to the other in a straight line without detouring around a whole lot of atomic potholes. Scientists think that graphene transistors could operate at frequencies of up to 1,000 gigahertz. That's 10 times the maximum of silicon. Another proposed use for graphene is in touchscreens. The topmost layer of a touchscreen has to be an excellent conductor of electricity so the device can sense your fingertip. The material we use now is indium tin oxide, but it's both rare and brittle. Even ground into powder, graphene retains many of its extraordinary properties, so it could replace graphite or other forms of carbon in anything from car tires to AA batteries to make them stronger or more conductive. The biggest problem with graphene, though, is how hard it is to make. I mean, peeling off a tiny sheet at a time with sticky tape isn't really scalable. We can grow graphene sheets by heating up a sheet of hydrocarbons like methane until the hydrogen separates, leaving only the carbon behind. But the graphene we get from this is mostly low quality. Basically, it's hard to create a 1-atom thick sheet of anything. And it's also really hard to get a completely pure sample of anything. And here, we're trying to do both. But then again, the silicon industry faced the same purity problem 50 years ago, and we eventually solved that problem with time and some money. So with some more time and some more money, I'm sure we'll do the same thing for graphene. Thanks for watching this SciShow Dose. If you'd like to help us keep exploring the frontiers,
Okay, so you should have at this point put into your guided notes some sort of summary of like what graphene is, maybe even why it's important. And we're going to continue forward with the guided notes. So there's also accidental chemistry. That's always fun. And what accidentally has been found by chemistry are a couple of discoveries you probably have heard of. So this polytetrafluoroethylene, it's a big word, is like, it's kind of like a plastic that is used for insulation of electrical cables, soil and stain repellents for fabrics, and coatings for nonstick cookware. So you probably have this chemical somewhere in your house if you have anything that's electrically insulated, or if you have any fabric, maybe like an outdoor cushion, or even if you have like some of this like weird kind of plasticky spatulas in your house. Saccharin was discovered by accident, and it's actually from tar. But if you have ever seen Sweet and Low at a restaurant, or maybe your family uses Sweet and Low, it's an artificial sweetener. It's like sugar. It's but it's from tar. Also, Post-it notes were an accidental kind of discovery. It was an adhesive someone was trying to develop that was only like kind of sticky. So it was perfect for something like a sticky note. You can temporarily stick something somewhere, and you can take it off with ease. So somebody thought it would actually be a really good idea for like bookmarks in a hymnal, because you could bookmark it, it would stick there, and you could take it off. So we're going to look at some careers specifically with chemistry, and there's going to be 5 main types. There's biochemistry, physical chemistry, analytical chemistry, inorganic chemistry, which is mostly what we're going to study in class, and then there's organic chemistry, which if you move on in your chemistry career, you'll likely be studying organic chemistry as well. So let's start with organic chemistry. What's that? It's the study of the structure, properties, and reactions of compounds and materials that contain carbon atoms. So organic chemistry all has to do with carbon, because anything that's living is a carbon-based life form, at least here in the universe we know about, or on Earth. So what kind of industries are going to hire organic chemists? Pharmaceuticals, if you're interested in any like drug making, developing, biotechnology, chemical industries, consumer products, petroleum, like anything with oil, or gasoline or anything like that. Those are all organic molecules. Inorganic chemistry, again, you'll probably become the most familiar with inorganic chemistry in our class. It's the study of properties and behavior of inorganic compounds, so ones that are not necessarily organic. We will deal with some compounds that will include carbon, but for the most part, we're talking about metals, minerals, organometallic compounds. So inorganic chemistry is actually kind of counterintuitively really important for environmental science. I actually studied environmental science. That was my original major in college. I taught environmental science at Verrado for a little while. And a lot of it has to do with chemistry. And in fact, my favorite kind of crossover of chemistry is environmental chemistry. There's a lot going on there that's really interesting. Fibers and plastics, microchips, even if you're like a tech person, there's a lot of chemistry that's actually happening with microchips. Mining ore, metals, paints, pigments, coatings. You can do some fun art stuff with chemistry as well. Biochemistry, like I said, that's more of like if you're interested in the medical field, right? Because it's the study of the structure, composition, and chemical reactions of substances in living systems, like in people or in animals. or food, like agriculture, right? So if you're interested in anything medicinal, dentistry, veterinary, food science, agriculture, all of those industries are going to use chemistry to some extent. So specifically like biotechnology, pharmaceutical companies, and university and government labs. So there's a lot of like cool careers that you guys could be exploring there. So just to let you guys know, they study processes like digestion, metabolism, reproduction, respiratory, so on and so forth. So if you're interested in your like, gosh, what is that called? Oh my goodness, it's in the field house. It'll dawn on me in a minute. But if you're interested at all in like exercise science or anything about our body, there's a lot of biochemistry there, right? In fact, like one of my favorite things to study in college too was actually like the biochemistry of the neuromuscular junction. Like my background is in psychology, specifically, I studied chemistry or neuroscience, and there's a lot of chemistry that happens in your brain, like a lot of chemistry. It's all chemistry, right? So I find biochemistry rather interesting. Physical chemistry. Again, this is a lot of like neuroscience kind of stuff as well. It's the study of how matter behaves on a molecular level and how chemical reactions occur. They study mechanism, rate, energy transfer, and when matter undergoes a change. So there's a lot of things like they study materials, develop methods to test and characterize properties of the materials. They get to use the cool instruments like the lasers and the mass spectrometers and the nuclear magnetic resonance. So like actually MRIs themselves use a lot of chemistry to function. Electron microscopes, like all those like high-tech, super cool, fancy lab equipment are all like using a lot of chemistry in order to function. So if you're interested in developing any kind of materials, even Wall Street, law firms, venture capital firms, they usually have a lot invested in these types of companies, and they have to understand what's happening with the company. Again, pharmaceuticals, and again, university and government labs. Last is analytical chemistry. This is the real tough stuff. This is things like the science of obtaining, processing, and communicating information about the composition and structure of matter. So if you're interested at all in like forensics, in anything to do with like, okay, maybe you have a sample of like blood, or you have a sample of like an unknown substance or something, then you can use analytical chemistry to break down what that substance is, or how much iron there was in the blood, or anything that you need to know about the substance itself. So we use knowledge of instruments, computers, statistics to investigate ingredients and organization of matter. So it can help support the legal process. Like this could be evidence in court. It's gonna, if you're interested in any quality assurance kind of job, food, drugs, water, they're all going to test their substances using analytical chemistry. And for that matter, too, environmental science will use this as well. You want to look at how many parts per million there are of a toxin in a lake or something like that. It also helps physicians diagnose diseases as well. So a lot of like phlebotomy uses analytical chemistry as well. So chemical industries, consumer products, foods, forensic labs, petroleum, pharmaceuticals, university and government labs, like they're all going to use analytical chemistry to a large extent, right? Last, polymer chemistry. These are larger, more complex molecules, which are called polymers, like many smaller pieces that have been stuck together. So these are cool. Like if you have any interest in technology, you're probably going to use some polymer chemistry, because you create, study, manipulate the characteristics of polymers to create materials with specific chemical, biological, and physical properties, like Teflon or Gore-Tex. Like a lot of like products are made with specific polymer chemistry in mind. Okay, so adhesives, agriculture, alternative energy, biotechnology, chemicals, coding, medicine, green, nanotechnology, oil and gas, rubber, and synthetic fibers. So one of the things that I'll show you throughout the year is that the Army uses a lot of polymer chemistry because they've created like lightweight, bulletproof materials. There's a lot of like specific combat related scenarios that they have to develop new materials for using chemistry. So there's a lot of opportunity to work within the military with chemistry as well. Okay, and this is a really fun use of technology. If you're like, or chemistry, if you're like me and you like food, which you're a human being, so you probably like food, then the next video is going to be inside a flavor lab. And just so that I can post this without, going over my certain limit, I'm gonna have you guys pause the video and watch this one. Remember that as you're watching this, you've got a section in your guided notes. You need to summarize this video in 2 to 4 sentences. So pause and summarize. Okay, so make sure that your summary is in your guided notes, and then we're going to do a check for understanding. Now, when I'm live with you guys, this is a little bit easier for me to do. You'll just kind of do this on your own to make sure that you have kind of gotten out of the guided notes what you need to, and you're free to use the guided notes as you're kind of checking yourself. What we typically do is I open another Socrative, and I have you just put your answers in there so I can see live with you how you're doing. But obviously that's not going to work today. So which type of chemistry field would be used to measure the level of lead in blood or the amount of carbon dioxide in the air? Should be analytical chemistry, right? That was one we kind of most recently talked about. All right, which type of chemistry field would be used to investigate changes that occur as food is digested in the stomach? Biochemistry. So like think biology. Biology and chemistry cross over a lot. Which type of chemistry field would be used to explain the energy transfer that occurs when ice melts? Physical chemistry. And in fact, that's something that you guys will accomplish this year in my class. You're going to be talking about the energy transfer, whether it's endothermic or exothermic, and you should be able to justify why. But that's for like 2 weeks from now. Okay, so I'm gonna flip through really quickly some chemistry careers, read through them as I'm clicking, because these can give you some preconceived like idea about what you want to do for your assignment today. So go ahead and take a second and read through these. High school chemistry teacher, that's what I do. Personal care chemistry could be like makeup and stuff. Cool. So that's not the last time you're going to see that list. You guys are going to specifically go to the American Chemical Society, where they have college and career opportunities. Now, I've already done all these clicking for you, and I've linked it into your assignment. So let me talk to you guys about what your assignment is. First, you guys, we are going to talk about pure and applied chemistry. So pure chemistry is just pursuit of chemical knowledge for its own sake. What is this? How does it work? What is matter made of? What element is this? We just want to know, right? Applied chemistry is research that's directed toward a practical goal or application. So you're probably going to do projects more related to applying your chemistry knowledge. Like, how can I use this to make something else better? How can I make a car that produces less pollution? How can I make a plastic that's more friendly to the environment, right? So we're going to take our pure knowledge and we're going to apply it to certain projects through the year. So first, let's talk about what career in chemistry might potentially interest you. Now, I'm not saying you're signing up to do this and I'm going to hold you accountable that this is your career path now. Just an idea to explore something else that might potentially interest you or see if something aligns with what you're already interested in doing. So the instructions are embedded in the document. It's the next assignment after this. Please take your time with this and put your best foot forward. Okay, first of all, this is going to be your first grade that goes in the grade book. And it's probably going to be there for like a little over a week because our next grade isn't until next Friday. It's also going to be my first impression of your academic work. Like I've already looked through, like yesterday's assignments were all kind of fluffy assignments, right? I've seen like your responses to the survey. The Socrative quiz didn't really matter in terms of like a grade or anything. They were just fun science questions. And the syllabus agreement is just a syllabus agreement. This is me seeing like, who are you as an academic student? I made it due by midnight tomorrow. So first of all, you're going to have plenty of class time to finish this up. So I don't want to give you homework. That's not my goal. My goal is just do it now and be done with it. But if you need to, you've got tonight and you also have tomorrow, your flex day to finish it. So don't feel too stressed out. So with SBG, you guys know that your grading looks a little different. So you're going to get an incomplete if you just don't turn it in. Okay, your incomplete at the end of the quarter turns into a 0 and drops your grade down. So make sure that you remedy any incomplete you have as quickly as possible. Throughout the year, 0, 1, 2, 3, 4 can basically be explained this way. 0, I'm not understanding this at all. I need lots of help. 1, I'm starting to get it with a little help or guidance for others. 2 is you can do it on your own, or with a little help. Or guidance from others. 3 is now I can do this on my own with few mistakes. And 4 is I understand this very well, and in fact I could teach it to others because I got it on lock. Okay, so how's that going to work with this assignment? When you look at it, you should see you're going to get an incomplete if I don't get this assignment turned in on time. 0 if you turn in just like chicken scratch work. 1 is you have answered a few questions, but you may have used incomplete sentences. 2 will be about half the questions are answered accurately, or you're giving me all answers, but they're inaccurate or they're incomplete sentences. 3 is mostly completed, mostly correct, mostly complete sentences. You may have some errors here and there, or you might have just given me a couple of one-word answers and forgotten to make complete sentences. To get a 4 on this assignment, all you have to do is completely fill in all of your information with accurate information and using complete sentences. Okay, that's all. All right, so at this point, you are to open up that document, click on the link, find a career that you like, spend some time browsing around. It doesn't have to be something that you're going to like definitely commit to doing for the rest of your life, but try to find something where you're like, oh yeah, that's kind of cool. I could do that. Or that's neat. I'd like to learn more about that. Or maybe you're already interested in something that is chemistry related and you can get some additional information on it. Again, due tomorrow by midnight. Just finish it in this class period if you can. And let me know if you have any questions. Okay. See you guys on Thursday, hopefully with a notebook, right? If not, no worries, but we are going to work on some notes on Thursday. Okay, bye. See you later.